In this video, we will introduce the concept of stacks. You must have seen a pile of plates or a pile of books or toys like these. Suppose we have a pile of plates. If I want to add a new plate to this pile, I can add only at the top. If I want to remove a plate, I can only remove it from the top of the pile. Similar, we can do with the books also or with the toy also. Same goes for the stack. So suppose if we have a stack and we want to insert an element in this. So considering that the stack was initially empty, suppose we insert an element M. So M can be sent into the stack from the top. So there is a variable which is associated with the stack which is called the top variable. So top would initially be here. Then we want to add another character A. So again we can introduce only from the top. So one more element goes inside the top and the top variable is incremented to point to the element which is at the top of the stack. Now if we want to add another element, suppose character C has to be added. So C can be added and top would be pointing to the top of the stack again. If we want to remove elements, then first the element which is at the top will be removed. So C can be removed and the top would now be back to pointing to A. So any element that is added or deleted from the stack is only from the top, and the element which is added last is the first one that is to be removed. So we say that the stack follows the last in first out principle or the LIFO principle. The element which goes in last is the first one that is to be taken out. That means only the most recently inserted object can be removed. So let's look at this representation of the stack. If this is the stack currently and we want to insert an element in the stack, that means we can add it only from the top. So if data element 5 has to go in the stack, it will go from the top, and this operation is also referred to as a push operation. Once that data element 5 is pushed into the stack, the status of the stack becomes this. Now if I want to delete an element from the stack, it can be only deleted from the top. So data element 5 will be popped out, and this operation is called a pop operation. In this stack over here, the top was here. In this stack over here, the top is over here. Once the data element 5 is deleted, top will now start pointing to data element 4 again. And as we know, the stack will always follow the LIFO principle, the last in first out. Let's see an example of a stack. So currently this is the status of the stack. There are 3 elements. 2 is at the bottom of the stack, then 7, and then 5 is at the top of the stack. So the top variable is pointing to the topmost element of the stack. If we want to insert a new element in the stack, that means it will be a push operation. Suppose we want to push an element or integer 1 into the stack. When 1 is pushed, it will always be pushed from the top. So when 1 is pushed, top will now point to the topmost element, and it is now pointing at integer 1. Now suppose we want to push an integer 8. So again integer 8 would be pushed from the top of the stack, and now the top variable will be pointing to integer 8. So whichever element is at the top of the stack, top will be pointing to that element. If we want to perform a pop operation now, So that means the element which is at the top, that will be removed out. So 8 is the element which is at the top. So 8 will be removed. So even though it might be present in the stack, but it will no longer be part of the active stack, and top will shift down. So this will be the pointer of the top. Top will be pointing to element 1. So even if 8 is present over here, it is considered as garbage value, and only this will be the active stack. We do a pop operation again. So now 1 is the element which is at the top of the stack, which will be deleted from the stack. As always, it will follow a LIFO principle, the last in first. So 1 would be popped out, and now top will point to the element at the top, which is 5. Another pop operation would result in 5 being taken out of the active stack and top now pointing to 7. If we do 2 more pop operations, we will be left with an empty stack, and the value of top at that point of time would be -1. Currently top is at 2, it can be 1, and if there goes another 1, then it will be still going further down. If the indices are 1, 0, then when the stack is empty, top would be referred to as by -1.